What's up, everybody, ladies and gentlemen, everybody out there? It's Philip 20, and I'm back. A lot of times I've talked about doing an air conditioning system for my house. There's a couple of things that I wanted to do, but I never came across the parts I wanted to do. I had the package unit here, and I talked about it, and I didn't want to do that one. I finally decided I don't want to put a giant hole in the wall. With a split system, I can do that. I have a coil here. It's been damaged. We're going to repair it. It's aluminum. I ordered some of the rods. They'll be in the next video. But we're not talking about the coil today. We're talking about this indoor unit. This indoor unit's got a 3-ton dual stage compressor. It's a Carrier Infinity. It's a really high efficiency heat pump. But my inverters, I don't want it starting a large load. And the lock rotor amps for this is, well, it's not labeled anymore. 66 to 39 amps right there. That's what it says. Lock rotor amps, LRA. And 66 to 39 amps is too much for a 230 volt inverter, even an 8,000 watt inverter that I have. So what I want to do is put this compressor in there. This has got 29 lock rotor amp. So that's should be good enough to start this compressor on the Magnum or the other one. I'm going to set it up to where it plugs into an extension cord. We're going to test and see if it starts after I swap it over, because I got to rewire the whole system. This system has 2 contactors. It runs in 2 different cycles. So one's at low speed, one's at high speed. I can't start this compressor, but I can start that compressor. So what we'll do is we'll take this small compressor, put it in this, and then we're gonna braze it up, weld it up, do everything you're supposed to from the manufacturer. For instance, there's still refrigerant in this system, and we have to recover it, put it into a recovery tank. Once that's done, we'll go ahead and swap this compressor out and put the new one in. This is a heat pump. It's got a reversing valve. It don't just do air conditioning, it does heat as well. This is also a Carrier Infinity system. So we can run a heat pump, single stage or 2 stage out of this, but I'm gonna do a single stage, stage 1, and that's how we're gonna set it up. We got to change the capacitor because the capacitor for this is significantly smaller than the one that's on here. By the way, this capacitor apparently went bad sitting in my backyard, because I know this unit ran when I took it apart. It's sat in my backyard for over a year and a half. So I don't need it sitting there no more. We're going to go ahead and do a project with it. Originally, it's got this black insulator on there. It's for sound dampening. It's also got a muffler for sound dampening. I'm more than likely going to leave this muffler in. This unit will probably take about 6 pounds of refrigerant to charge it. Maybe a little less, but probably around 6 pounds of refrigerant. This contactor will have to go, this one will have to go, and I forgot to turn my phone off. Now that conversation is over with my insurance, because, well, scammers be scamming, let's get started on changing this compressor. Okay, ladies and gentlemen, apparently all the refrigerant was recovered a year and a half ago whenever I did the system. My apologies. All we got to do now is unsolder, or technically you're supposed to cut it, but as a heat pump technician, making those cuts are very difficult, and then putting it back together. So I'm gonna go ahead and unsolder it. Let me grab the torches. So we got our oxygen acetylene torches right here. We're gonna turn the fuel on, And as soon as we're done, we're going to turn the fuel off, but for the meantime, we have to have it on to melt the silver. I want to melt the copper that inserts into the fitting on the other side. So this piece of metal is the one I got to heat up first, because the other piece of metal, it won't allow it to detach from it. It's the inside piece that has the solder soaked into it. And I'll use a small pair of channel locks to get it attached. Detach, there. As you can see, I'm heating up the pipe that inserts into the copper fitting. And I want the silver metal look wet. In order to pull it out, it needs to look wet. Well, it didn't look wet, it just ruined it. But that's not a big deal because I can cut that off and refit it. Sometimes that happens in 15-year-old heat pumps. And again, I'm going to heat up the fitting that goes into the copper fitting itself. I'm going to give it some more heat. So now, you turn the oxygen off, try to blow it out. If it don't blow out, then, well, you don't never want to blow oxygen into an oiled area because it can cause an explosion. Locally, somebody had died from one of these by pressurizing the system with oxygen instead of nitrogen. So, 2 people died from that. Terrible tragedy. They were just trying to go to work. They was doing it with an oxygen tank instead of the appropriate equipment. Now I've got a nitrogen tank. We'll see that here in a little while. Now, what I got to do is let this cool off, and then we'll be right back. So I figure I would go ahead and talk about why I want to do this while we're letting it cool down. This evaporator coil and this condenser came out of jobs. This evaporator coil is a 3-year-old coil. Somebody was trying to melt the ice off of their coil instead of have the heat pump technician come out and fix it, and they accidentally damaged it. It was a $950 mistake. I'm sorry. I hate that happened to you. But it gives me opportunity to try to learn how to fix aluminum damaged coils. We're going to try to fix this. We're going to pressurize this coil, and we're going to see if we can fix it. Also, this condenser came from a system where the indoor fan motor was $600 just for me to purchase. That don't include any profit for markup. Sorry, I didn't mean to touch the microphone. So these coils and this fan and stuff like that, well, it's got a piece of damage right here on the top. It's out of focus, I'm sorry. Maybe if I zoom in here. right here. Got a damaged spot right there. And on the way home, I may have damaged it right here with my torches falling over on top of it. So if we can fix this one up here, then we're gonna try to fix one of these. If they're leaking too, if they're not, then I'm not gonna try to fix it. But you know, it's the same material on the top, except these are, you know, have fins in between. So what I would typically do is remove the fins in the center carefully, if this was copper, and then I would solder. This looks like it's a pretty good ding. I hope it's messed up so I can try to learn how to fix these. Like I said, this coil don't work. I'm gonna try to fix it with the aluminum rods that I ordered from Amazon. I don't have those yet, so I can't give you a link to suggest to use it because it probably ain't gonna work, but if it does, I'll leave a link in the description and I'll guarantee that it works, because I promise. I'm gonna put 300 PSI on this because it's a 300 PSI working pressure system. I'm gonna pressurize this thing hardcore. What I'll do is I'll seal off this side, and then I'll put this tube inside there like that. Then I'll put a service port right here, and I'll pressurize it with 300 PSI and nitrogen. And nitrogen has a very low temperature glide. And so that means if the pressure goes from 80 to 90 to 70 or 60, it stays around the same pressure. It drops. If you reduce temperature, everything drops in pressure, but it's pretty close. For instance, the liquid state is negative 195 degrees Fahrenheit or something like that at atmospheric pressure, so whatever. But we're gonna fix this up, and we're gonna fix this up, and hope you guys enjoy the haiku appreciation in the background. Go America, or not, whatever you don't like, or whatever you like, whatever floats your boat. But back to replacing the compressor. So typically, if I was changing a compressor, everything would very carefully be organized. For instance, this right here we're gonna have to pull it out, and then we're gonna take this cap cover right here off. We're gonna look in there for oil. If there's oil in there, that means that this compressor's been leaking refrigerant out, right, of the electrical connectors. So I don't see any oil. That's a good sign for the compressor itself, and a good sign to say, hey, I found a leak for your the system if it was ever leaking refrigerant, because sometimes that happens. Now we're going to take, it's got a tab on this one, and we're going to try to pull on the tab, wiggle it, pull and wiggle. All right. Not all systems typically have this type of terminal system, and for sure the one we're replacing it with does not have that type of terminal system. And it's got tinier wire because, well, it's a tiny compressor compared. So what we'll do is cut this plug off and wire this compressor by the manufacturer specification to the manufacturer specified capacitor. This compressor actually has a suction accumulator already on it. What we're going to do is basically we're going to take a ratchet and a 1/2-inch socket, pull these bolts out, and we'll move some of this copper fittings out of the way. So I'm gonna go ahead and set our new compressor in, and we're gonna bolt one bolt down to it. So now this little pipe here, I'll cut it off, solder it into this joint here. I'll cut this off here, and this pipe right here will fit inside of this big pipe, and I'll need to take the bullet piercing valve out and solder up the hole that's on the top, and then I can get to doing the electrical repair and rewire. I'll go ahead and trim this. I'll take this out soon enough. But first, we need to go ahead and figure out what we're doing with the electrical. Multi-stage crap. So, for now, what will happen, we'll set it up to run an air conditioning. The reversing valve needs 24 volts to operate. The contactor needs 24 volts to turn on and off. So, what we'll do is we'll energize that reversing valve continuously and run the contactor on and off. That powers the fan and the compressor right here. And here is the compressor wires. I will get the model and serial number off the other side of the compressor with a phone, take a picture, go see what capacitor it needs. I've got the capacitor here, I'm sure, and wire it up. So, ladies and gentlemen, I've pretty much gotten to the point where I have to move the machine outside and run wire to it. Now, it still needs the fan motor. I've got some used fan motors that I can use if they still work. We'll find out how they work. If not, I've got new fan motors. I'd prefer not to spend $50, $150, whatever it costs for a new fan motor. I got $30, hopefully in this coil already, to find out if that stuff will work. The rest of it, I've had stuff just lying around. If I can just find a motor that functions well, and I can put it on this fan blade, I'll be good to go. Otherwise, basically, I've gutted this thing and I'm restarting from scratch. It's going to be a single speed instead of a multi-speed compressor, but it's fine. I'm happy with that. It's got a very large coil. It's got plenty of room to remove heat. Nobody's going to be dissatisfied with the amount of heat that it removes. The fan, it'll be on super duper low speed, I'm telling you. I'll put a resistor in between the power circuit and run it at like 100 volts, maybe 120 volts at the fan. But with a resistor, you know, it'll drop the voltage from 230 down. And that will reduce the amount of current and save a little bit on the electric bill. Anything I can do to reduce the amount of power this thing consumes, but I want it to have adequate pressure. So we've got our compressor installed. Basically what we need to do is run a line set and install this. So this is the end of the video for today. Once we get done with this, I'll get everything I can done. First, before I buy a refrigerant line set, I gotta see if this system can be pressurized. So I'm not going to go out and buy refrigerant lines yet. This system's got to be able to hold pressure 300 psi for 4 or 5 days. Once we figured that out, because you're going to see in the video me working on this anyways. So we're going to see if that works. If it does, we're happy. If it don't, too bad, so sad. I got to wait for another coil. You know, I'm not spending $300 on a coil. I'm just not. So we've got this thing halfway done. I would say the compressor would probably be the hardest part. It takes a long time to work on a compressor and move stuff around, prepare everything, and on video it takes twice as long. So we're gonna get this done. This is the end of the video for today. I've got soldering rods on the way. You guys will see that video as soon as they show up, and then we'll do another video. If it does not leak, I'll make another video, leave a link in the description for those soldering rods, and you guys can use it if you want. If it don't leak, then that's fine. If it does leak, then, well, I can't recommend the product. It's crap. And then we're gonna get a line set for this thing. It don't have to be real big, just because of the size of the compressor. It don't flow a lot of refrigerant. There's a very good chance that we might have to do something about the expansion valve right here. We might have to change it. So if we got to change it, we got to change it. And this has a metering device at the bottom for heat mode. Right now, it's not going to run heat mode. It's just going to be running air conditioning. We will eventually get to that heat mode part. So this is the end of the video. Sorry it took so long, but this is Philip 20 with solar power, electricity, and electronics. Peace out. See you next time.